Next, the continuous interest formula, which is a lot like the compound interest formula, except instead of having the 1 plus r over n here, we have an e. And we put the rate, the interest rate, up into the exponent here. So let's talk about these variables real quick. A is the final amount after t years. P is still the principal, your starting amount. R is still your annual rate of interest. Now, E is just a mathematical constant. Remember, if you type this into the calculator, e to the power of 1, it's this number, 2.718281828. It's just, it's like pi. It's just a different number. E is just a number that's irrational, just like pi. And again, one side note, that annual rate of interest, you're still going to want to take that percent and divide it by 100. That R should always be a decimal. Don't write the percentage form of it. So let's talk about a few of these. Billy invests $10,000 in a savings account, which earns 0.5% interest. Write a function to model this situation if the interest is compounded continuously. So that means it never stops being compounded, whereas before, in the previous video, it was compounded once or twice, 3 times, however many times per year. This is compounded continuously. So the equation is A equals P times the constant E to the RT. Now, the A is the formula, the beginning. There's always going to be an A in there. And that's the final amount. The P is the initial amount, 10,000. The E is your constant. That's going to always be in the formula there. The R is that 0.5 divided by 100. And if you're not sure what that is off the top of your head, you can divide by 100 in the calculator. And maybe that 5e to the negative 4 is not very helpful, but just remember that's 0.0005. That's a 5 with 3 zeros in front of it. So that's the what I'm going to type as the rate here, 0.0005. And we don't know how many years, so we're just going to keep a t right there. And that's how you would write the formula. Now, if we talk about solving, we are going to add some other variables in there. So let's talk about a different one. Suppose you have the opportunity to invest in a fund which earns 1.2% interest compounded continuously. Find the following. The initial investment needed to earn $6,000 in 8 years, and B, the value of initial $500 investment after 4.5 years. Well, let's start with this one. A, the initial investment needed to earn $6,000 in 8 years. All right, so that means that my A is 6,000. And I don't know the initial investment. That's what I'm trying to find, so I'll keep that as a P. I'm going to have that mathematical constant in there, E. I know my interest is 1.2%, so 1.2 divided by 100 is 0.012. 0.012, and I know my t, my number of years, is 8. So I need to solve for p here, and this is pretty simple if you just consider that we can type this into the calculator, e to the power of 0.012 times 8. So I'm going to do that real quick. I'm going to zoom in a little bit so you can see it really clearly. So my E button is right above the natural log, so if you do second natural log, you can pull up the E to the power of whatever it is you want to get. In this case, we want to get 0.012 times 8. So it's going to spit out a number here, and it's about 1.1 decimal. If it's all right with you, I'm not going to change the number just yet. I'm going to keep it in the calculator right here. You'll see why in a moment. To get this p by itself, this is multiplication in here. So we can divide both sides by this amount, e to the 0.012 times 8. E to the 0.012 times 8. And when I do that, these will cancel out, leaving me with P equals $6,000 divided by e to the 0.012 times 8. That's a multiplication sign right there. Now I have that denominator right here, and what I want to do is multiply that, or sorry, divide it by 6,000. So that's what I'm going to do next. So I'm going to have $6,000 divided by this 1.1 da 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 da. So what I can do in the calculator is a little trick here. If you do 6,000 divided by second negative sign, that's your answer key. So you can do 6,000 divided by second answer, and you're going to get the exact decimal in there. So it's about $5,450.78. That's how much you would need to start with in order to end up with $6,000 in 8 years. Okay? Let's talk about this one. The value of an initial $500 investment after 4.5 years. All right, so I don't know A in this case. We're going to start with A because I'm trying to find A. The initial investment is $500. Got this E to the decimal is going to be the same, 0.012, and this time we've got 4.5 years. My T is 4.5. So this is just pure calculator work. And I'm just going to type it in just like this. Watch and see how I do it. So keep the equation right there and calculate it right here. 500 times second natural log to get the E, 0.012 times 4.5. And that's going to, after 4.5 years, that $500 turns into $527.74. And that is how you would handle that. Thanks for watching.